Hi, thank you so much for being here this early. My name is Maria, and it's my honor and pleasure to do this introduction into the area of computational design, digital fabrication, and architecture. So architecture as a discipline has had a long relationship with computation and digital world for quite a long time. And this fascination has been expressed in a variety of projects and proposals ranging from algorithmic design approaches as well as conceiving of architecture as a moving machine or as a physical machine in itself. One of the early examples of that fascination is this Computer City proposal from 1964 by Dennis Crompton from the Archigram Collective, where he's envisioning a city that is strongly reminiscent of diodes and electrical components and really trying to see it as more of a flow of information rather than an urban sprawl that we are somewhat used to and still used to today. Trying to identify this computational approach towards seeing the city of the future that would enable this plug-in city that would grow in a very different type of mode. One of the more famous archigram projects, the Walking City, has a very different approach to this relationship between architecture and computation, or architecture and machines, if you will, by envisioning the architectural building itself as a machine for living and asking questions about how do we design machines rather than buildings, asking questions about collective living and international boundaries and the blurriness of those boundaries. Later in 1970s, when more and more computational methods and hardware has been becoming available, a new series of projects have emerged that were manifested in prototypes rather than proposals on paper. And again, one of the more famous ones within that range is the SEEK project by Nicholas Negroponte at the Architecture Machine Group that is exploring the relationship between machine-built environment and its occupants through creating this prototype where a CNC machine is built moving blocks inside of an enclosure. An enclosure is simultaneously occupied by a group of gerbils. So as they move around, they move the blocks, they knock them down, and the machine is supposedly learning their behaviors and gradually adapting the built environment towards their needs and desires. In 1976, Cedric Price and John Fraser have developed a generator project, which has a very similar approach to architecture as a reconfigurable machine or architecture as a space that can adapt to its users' requirements. But maybe even more importantly, this project is touching upon the idea of a generative design tool where there is both physical and digital design tool that you can interact with. And by moving these prototypical blocks around, you can see the results of your design decisions on the screen and on the plotted paper. Unfortunately, most of these revolutionary ideas of 70s and 80s have mostly remained prototypical and speculative, largely due to both the technological ambition, but also to the economic and political realities of the time. What did happen beyond speculation in architecture and computation and architecture and robotics is the construction automation boom. And here the goal is, of course, very different from the revolutionary ideas of the 70s. It's not necessarily to create new systems, but rather to automate and optimize existing construction systems, often by automating existing construction equipment as well. Kind of staying within a very conventional way of designer designing a product, then the product goes into the engineering office, the engineer has to somewhat magically figure out how to make it buildable, and then the contractor actually executes it, which is a somewhat outdated concept, which probably is the reason why today's construction industry is one of the least digitized industries in the world. In contrast to that, the field of architecture and architectural research in computational design and digital fabrication, which I have a pleasure to introduce here, has a very different approach to automation and computation. The idea here is not to merely optimize an existing process, but rather to explore new design possibilities, new fabrication methods, and new materials that are enabled by the technology that is available to us. This undertaking is often performed by conducting real-scale architectural demonstrators, experimenting and developing systems at a one-to-one scale, taking into consideration a variety of parameters throughout the design process. And to bring up a few of those examples, or a few examples of those parameters, some of them may include digital fabrication techniques and robotics. For example, this project from the Gromazzo and Kohler group at the ETH in 2005, which is interestingly the first time an industrial robotic arm was used for an architectural task at an architectural scale. As well as structural optimization parameters, as can be seen from the work of Caitlin Miller at her lab, Digital Structures Lab at the MIT, where she's exploring design optimization for structural performance, taking into consideration architectural design, structural efficiency, as well as the fabrication constraints, all within a single design tool or within a single computational design tool. Another example of a parameter that can be considered is material parameters, and a good example of that is the Knit Candela project from the Block Research Group in Zaha Hadid Architects, where a custom computational design tool was used to knit this tensile structure that was then used as a stay-in-place formwork for a concrete shell that was sprayed over it. I could go on with the list of my favorite projects for quite a while, but I'm gonna stop it here. And to conclude, I would like to summarize the current state of the field of computational design and architecture as moving away from a conventional way of designing, where it's a design and then execution, but rather taking into consideration material parameters, fabrication parameters, and structural parameters, and treating them as an inherent part of a design process, creating systems where all of those players become part of one undertaking and are continuously influencing each other towards a balanced relationship within a design process. Without further ado, I would like to introduce our first keynote speaker, Stefana Parasco. She's currently an assistant professor at the Princeton University. She's received her PhD degree at the ETH Zurich, where she worked on a variety of research and teaching projects focusing on computational design and cooperative robotic fabrication of spatial structures. Her work has been exhibited at international venues, such as Milan Design Week, and published in peer-reviewed publications as well as architecture publications. Stefana has extensive experience in academia and practice, and in between architecture and engineering, and is currently focusing on temporal design and fabrication strategies.